So, hi once again. Welcome on the next lecture from RS School. My name is Paweł Waszczyński, and today's subject is responsive web design. So, let's get started. So, the agenda for today is, first of all, I will give you a brief introduction about the responsive design, some theoretical background, I guess. Then we will dive into three distinct areas of responsive design: responsive layout, responsive typography, and responsive images. So, introduction at the beginning. So, what is responsive web design? So, in a nutshell, responsive web design means that the design should respond to the device parameters. So, devices that we are using, like our smartphones, tablets, monitors, have different parameters, like screen size. They support different interaction devices. We call them touch controls. They can have different orientation, like landscape or portrait. And these parameters are often called media features, and we can use media queries as a way to query the website, to query the device, and modify the website depending on the device parameters. So let's have a look at the complete list. Just quickly have a look. So basically, this is the documentation from Mozilla, and you can find here the complete list of media features. So, like compared to other specifications like events and APIs, this is pretty short. So you can see, like, we can query whether the device supports hover, what kind of orientation is currently on the device, what is the resolution, what is the width of the device, what's the height, and so on. So basically, the list is pretty short. And actually, the number of media features you are using is even shorter. Usually you use 2 or 3 of them. So in practice, for a developer, responsive design is just writing CSS styles in a way that display the website correctly on all devices. So usually you do it in CSS styles, but sometimes you can also use JavaScript. I will show you an example of that. So at the core of responsive design, we are using media queries, and we are targeting breakpoint widths. I will also show example of those, and we are writing a different sets of CSS at different breakpoints. So media queries. So this is the simplest example. So like I said, they allow you to make adjustments to the page based on the screen size using breakpoints, and also you can use other features apart from screen size. So on the right side, you can see the simplest syntax for media queries. So you specify the mode, let's call it the mode. So the first media query is for the screen. The second one is for the printing. So for instance, when we want to print a page, and we can use the logical operators, for instance, and in the parentheses, we can specify additional media query conditions. We will see those shortly. So on the next example, you can see that after and logical operator, we used min width media feature. So in this example, we are saying that if we are showing the content on the screen and the minimal width of the device is at least 400 pixels, then we want to apply this piece of CSS. Then we have a second media query with different device width, which is 800 pixels, and we are changing slightly the styling. And what is important when you will apply media queries, it's important to have the correct order. So if you are using, for instance, min width media queries, always have them in ascending order. If you are using media queries with max width, the order should be descending. Otherwise, the styles will be applied in the wrong order, and you won't have the result you want to achieve. So what are the other things that are commonly done with media queries? So you usually change the font size, tweak it slightly, make it slightly bigger, slightly smaller. You can load different images using background image CSS property. You can change paddings, you can change background sizes, basically anything you want to do, but those are the things that are most commonly done. Yet another example. So on the previous example, we used only min width, max width. So here you can see I can write a media query that queries for hover feature and also for orientation. So we can apply some specific CSS based on the orientation. So if we are in the landscape mode, we, for instance, want to use a flex direction on our flexbox container, which is row. If we are on the portrait mode, we want to use column. And like I mentioned, so sometimes you may want to use JavaScript and execute some piece of code depending on the media query results. So there is a JavaScript API for it called match media. So basically, you just call this function and provide it a regular media query, and it returns you a media query object. So it has the main property is like matches. So basically, it specifies whether at this time the media query was truthy, and then you can apply some logic based on this condition. Also, this media query object has it supports observable patterns. So basically, you can subscribe to changes. So for instance, here we are creating a media query object based on this query maxed with 600 pixels, and then we are registering a callback screen test. And then each time this media query condition will change. So for instance, we go from portrait to landscape mode, and we toggle between those 600 pixels, the function will be executed. So how you can test or know what media queries are being applied? So you can use developer tools. I will show it to you on the upcoming slides, where we will have some real pages to examine. And also you can use some pages like this media query test.com. So let's have a look what kind of output it will give you. So this is the media query result for the feature of my monitor. So as you can see, media type is screen. What else interesting we have? So width in pixels, it's more than 1500 pixels. I'm in the landscape mode. I'm using a mouse, so currently media query hover will be supported. Pointer fine means that I'm using high precision device, which is a mouse. So if you want to know all the media queries that are supported and the results, you can use this page and quickly get a result. So how to approach responsive web design? So first of all, plan when you are planning to do a web page, plan which devices you are going to target. So it's whether it's going to be only smartphone, tablet, or all sort of devices. Use wireframes or mockups to have a high-level overview of the design. Create at least one wireframe or mockup per device. There are tools like UXPin or Sketch where you can play around and create a design for different devices. So next thing, when you are planning, those are aspects to consider basically when you are creating the design. So you have to keep in mind what will be the size or orientation of the device. And for instance, when you are viewing the page on the desktop, then some elements should be bigger, some should be smaller. So for instance, on the desktop, you will have a really big header and small menu item buttons. But when you will go to the mobile phone, then probably you will want to make your header slightly smaller, but on the other hand, make the buttons bigger because you are not using the high precision devices like a mouse, but you are using your fingers. So make those things, keep those things in mind, like some things should be smaller, some things should be bigger. So like I said, interaction medium. So the things that we are using, those are touch devices. We are using mouse, we are using keyboard. So remember that on touch screens, there is no cursor, so it's hard to determine a click. So like I said, so clickable interactive elements should be big enough to allow you to easily tap it with your finger. Also, some interactions could not be like even possible, like double click or right click is not possible on your smartphones. So instead of having those features, oh sorry, okay, there was a question, but I will answer it later. So yeah, so like double click or right click is not possible. So instead you need to plan for alternatives. So for instance, you may want to display an additional context, an additional content for what the user has selected. Also, some things are really hard to like figure out on the mobile devices, like tooltips, and there is no hover feature, so you should also plan for those. And on the other hand, on touch devices, you have features like swiping, so you should remember to allow users to do those, especially on image galleries. And probably last thing, so keyboard shortcuts. Yeah, of course, with the keyboard, we can use keyboard shortcuts, but on touch devices, we don't have those. And this is an example. So this is like an Outlook web application. So for instance, when using it on a desktop, you could use your right button of your mouse and just show the context menu. But here on the touch device, you don't have it. So for instance, you need to support a different way, like tapping on the rows on the emails and then showing the additional contextual content. So like 3 conversations were selected. So those are the things you need to remember. So some features will need to be implemented in a different way on desktop and on mobile devices. There are also strategies for showing, hiding content. So you have 3 options. Basically, you can scale the content. So for instance, here on the first example, you can have this layout on the desktop, and when you make it smaller, all the content just gets smaller, it just scales down. Another approach is like swapping, so replacing how particular piece of the layout is implemented. So for instance, Here you might have here menu items, and when you make it smaller, you, for instance, can make it an expandable menu. So when you tap, it will expand. And the last strategy you can use is just not showing some pieces. So for instance, here, let's say this is a web application and we are showing some advertisements here in the right on the right side. So we can assume we can make a decision that on the smaller devices we will simply just don't bother the user with this content and we will simply omit it. Okay, so mobile first approach, a few words about this because you will often hear this term. So basically over I think a few years ago, mobile internet usage has surpassed the desktop. It was, I think, in 2015 or 16. And right now, when working on the projects, we usually follow the mobile first ideology, which in a nutshell states that the mobile design is the hardest and we should do it first. And also the mobile first approach drives the design of essential features. So we should have only essential things on the mobile device and then progressively add new features and more content as the size of the device grows. Yeah, that's what I said. So progressively add something. And also when thinking and doing mobile first approach, yeah, you can of course start with wireframes, but wireframes are usually static. So just play around with the browser, start with a small screen, slightly increase the width and just analyze how the page looks. So when the things start to look weird or bad, then add additional breakpoint, like a media query, and just style it so that the page once again looks nicer. You can use emulation mode in Google Chrome for fast development and add devices. So let's have a look at some simple examples. So I will be opening my DevTools using F12, and we can start like following this approach. So for those of you that don't know, so basically you can open your DevTools and toggle the emulation mode, and then you can simulate the viewport of particular devices. So by default, there are some of them already defined, but you can't edit those. So if you are working on the layout for particular device, you can add a custom one, give it a name, width, height, device pixel ratio. I will explain it on the later slides. And you can decide whether this device should have mobile features or desktop features. So let's close this guy. Yeah, so let's say we want to work on the iPhone. So like I said, with mobile first approach, you start with a small page, so it looks pretty nice. Then you start to resize it. Then at some point you realize that things probably are not so eye-catching anymore. So like this image grows, still grows. So probably that's not the best design. So you have to scroll and see the image in the full dimension. So that's definitely not the kind of experience you would like to have. So once you figure out the points in your layout that when the layout starts to look weird, you can start adding media queries. So let's have a look. Let's pick one of those. So we can increase it, and here that's the first change. So we realize that at some point we don't want to have the text span the whole width of the device, but we would like to have it like a shorter with the padding. So we can have a look at this element. So I wonder if that's gonna be the one. Not exactly. This guy. Oh, something appears here. Yeah, so there you go. So as you can see, because the width of our design of our device is more than 50 ems, the media query kicks in. So basically, some additional styles are being applied. Let's have a look at the other one. So for instance, here we can see we have boxes. So if our device is smaller, we see big image. When it grows, we start to see an additional, a different layout. And why is that? Because the width of our page is more than 650 pixels. And it's more than 900 pixels. Yeah, so we can see pixels here. And basically what we say that if the width is more than 900 pixels, then the max width of the boxes should be 50 ems. So this is why those items are not growing more than 50 ems, and we can see all of them in one row. We have a flexbox, we have flexbox, flex wrap. So this is how you can approach the mobile first approach. Yeah. So it's really hard to think about all possible devices. There are hundreds of them. So when you will create your website, think about adding Google Analytics to your page and see what are the most commonly used devices that are visiting your page, and consider testing for those devices. You can use, for instance, Google Analytics. Pixel perfection. So as far as I remember, on your previous homeworks, when you were doing the designs, there was a requirement to make them pixel perfect, which is perfectly fine for pages that are not responsive. But when you are creating a responsive site, just forget about pixel perfection. Of course, you can have like a reference width of the design and make it pixel perfect for this one particular width, but then as soon as you start resizing and playing around with different widths, it doesn't make any sense to be pixel perfect anymore. So in responsive design, I would suggest to more think about the minimum and maximum values. So for instance, the paragraph shouldn't be smaller than 100 pixels and shouldn't be bigger than 300 pixels. And also try to use relative units like percentages, ems, rems, and try to avoid pixels. Okay. So first category is responsive layout. But before we even begin, there is one thing you need to remember to have always on your websites if you are creating responsive websites. And this is meta tag viewport that has two parameters inside the content attribute, which is device width and initial scale. So what it means? So basically the browser reads this meta tag, and depending on the content, it can apply different rendering mode. So with device width, tells the browser that it should render the page using the device logical width. I will talk about logical versus physical width on the later slides. So for instance, your mobile device can have, I don't know, 500 pixels width. So it tells the browser render the content as it would have 500 pixels. And initial scale, this is used for initial scaling. So when you visit the website, you can pinch it and zoom in, zoom out. So it just tells the browser to use the initial scale of 1, so without scaling. So without the viewport meta tag, mobile devices will render pages at the typical desktop screen. I think it's like more or less 900 pixels. So basically you won't have like a desktop experience. So remember, if you don't have this meta tag, things get messy. But of course, if you are creating a website which shouldn't be used on the mobile small devices, then just remove this tag from your HTML. Holy grail of layout. So I decided to mention this thing. So a long time ago, there was this task created on one of the very popular portals, I think a list apart. So basically, most of the sites are using the same layout. Like you have a header, footer, main content, left sidebar, right sidebar. And for a very long time, it was very difficult to create this kind of layout, and to make it responsive, it was even harder. So right now, because we have Flexbox and CSS Grid, achieving this kind of layout is very easy. So if you ever, there is a question, how to forbid mobile browser from allowing to zoom in. I don't remember exactly, but I guess there is an attribute for it, but I don't remember it by heart. It's a question from Przemysław. Okay, so going back to Holy Grail of layout. So right now we can have a Flexbox, we can use CSS Grid. So basically, every time you will create a page that has like more or less the standard layout, just read about it and have a look at sample implementations using Flexbox and CSS Grid. And also you can, when you read about it more, you can see how lucky you are. Basically, a few years ago, it was pretty impossible, and it required like ninja skills to do this kind of layout. But right now, it's really, really simple. And what is even nicer, you already had the CSS Grid and Flexbox lectures, so those two standards are responsive by design, so very often you don't need to even use media queries. So just have a look at the Holy Grail of layout. So responsive layout with Flexbox. So what you need to know from Flexbox are essentially two properties, like a flex wrap and flex. So flex wrap is responsible for wrapping the content into rows or columns depending on your flex direction, and the flex decides, tells the browser how the elements should respond to the available space. Should they grow, should they shrink, and what's the ideal width? So usually you will use Flexbox for things like menus, so or cards. So let's have a look at some examples. So those guys are using Flexbox. Yeah, so display flex. So looks fine on the like big device when we are shrinking it because we have a flex wrap. So things automatically respond to the smaller width. So it's already responsive, and even now, probably yes. So right now, when we hit some breakpoint, even the flexbox got disabled, and we can see the items stacked one by one. So this is very often what will happen. And a different example, when we get really like a small device, instead of having this menu items that are expandable, when you click on those, you can see that using the flexbox, you can make them like render all at once. So that's one use case for a flexbox that you can use often. And the second one, I think something similar I already showed, like it's using a cards. So let's say you have like a card gallery. Once again, we are using the flexbox, display flex, and flex wrap. And as we are making the things, the device with smaller, the different media query rules are being applied. Okay, so for instance, here we can see if the width is more than 40 ems, we are applying flexbox. But if things are smaller, then we are not applying flexbox, and things are rendered one after another vertically. CSS grid, as I was really talkative when I was talking about CSS grid, and the responsive features are already covered. So if you want to know the details about CSS grid and how it fits into the responsive web design, just check my previous lecture. So basically it boils down to using functions like repeat and so on. So let me just take a sip of coffee. So another category is responsive typography. So short introduction before we go into the details. So as you may already know, there are currently many font providers. Probably used Google fonts, but there are also different sites like Adobe fonts. And basically you don't need to use just the boring fonts anymore. You can choose from a variety of fonts. But why I'm mentioning about it? So basically, when you will be using your fonts, choose them carefully. So use quality fonts that are designed for the web. So some fonts just doesn't look good on your web applications. So some are designed for printing. Some will look nice when the font size is smaller. Some will look nice only when the font size is bigger. So don't use one font for everything. And also don't go too heavy into the other direction. So don't use too many fonts. Each font file is pretty heavy. So just maybe pick 3 maximum or 4. So an example, so basically Smashing Magazine, very popular website. So they are using different fonts for the navigation, a different font for this widget about the author, different for the text, so and also different for the quotations. So try to play around with the with your fonts, but don't use too many of them. So what are the goals of responsive typography? So basically, two most important are keep readable line lengths and text sizes across different viewport sizes. So we don't want our text to be too long, too short, and to have too many words in one line. And also to keep reading comfort on a high level, and this is called vertical rhythm. So basically, we don't want to have lines too close to each other. So how can we achieve those goals? Using media queries, relative units, and also by implementing modular scale for our font sizes. So I will talk about those on the next slides. The implementation is pretty easy, so there aren't too many CSS properties that you need to know. It's font size, line height, and the width. And also, before we proceed to the next slides, one thing that you should be aware of. So the base font of the browser. So each browser has a default font size. It's specified in the settings. So this is a screenshot from the Google Chrome. And usually browsers have a default font size of 16 pixels. So if you don't change anything and you start using, for instance, paragraphs, then the browser will use 16 pixels. Of course, other elements like headers, H1, H2, H3 will be bigger, but this is the base font. So when talking about responsive web design and responsive typography, we want to move away from using pixels to something which is more flexible. And this more flexible thing are relative units. But before we go to the relative units, let's examine what we have. So we have pixels. Of course, you know them. So those are absolute units, but there are drawbacks. So some browsers don't resize the text which is in pixels. I remember that old IE did that. So you know that you can open your browser and you can just zoom in, zoom out using control and scrolling wheel. So some browsers just won't scale your web page if you are using pixels properly. And also, even bigger drawback is that pixels are not flexible. So if you are using pixels all over the place and you want to make a global change, then it requires plenty of code changes. And also, there is one additional drawback, but I think I will mention it later. So percentages. So usually you will use percentages not very often, but for sure in one place. So you will set font size to 100%, and basically what it will say that it will take the value from the browser settings. So font size 100% means go to the browser settings and take this setting, which I showed you on the previous slide, which is, for instance, 16 pixels. So as you may imagine, this is already responsive. So if you change the browser settings, so if the user visits your website and the user has for instance, bigger default font because he has like some eye issues or something, then the content on your web page will be automatically bigger. Another responsive unit is M. So basically 1 M unit is a unit which is based on whatever the current font size is. So yeah, it sounds pretty weird, but basically Each element on your web page without any styling will have like its own default font size. So when you start to style this element using this M unit, you are taking this context, which is the default font size, and you are making it smaller or larger. So for instance, if you have an H1 element and its size was 55 pixels and you want to convert it to Ms to have a responsive design, then you divide it by the 16 pixels, which is the default browser size, and you have the value 3.4 Ms. So this is the calculation you need to do if you are if you want to know what would be the size of the element, what would be the font size in pixels. So take the target size divided by 16 pixels and you will have a value in Ms. But Ms are tricky. So the first tricky thing is that some other CSS properties like line height, if you are using Ms for those CSS properties, then the context is already changed. So if you apply font size, if you apply M relative unit to font size, then the line height is already using the new font size from the font size styling. So it's pretty complicated. So you have to keep in mind that 1M on line height will refer to the already overridden font size on the element. And also the another tricky thing is that if you start nesting your elements one in another, then the context, so basically this context, so the font size, like the default font size changes. So it's not always 16 pixels, but it is the font size that the element would have without any styling. So if you have elements that are nested in each other and each of them has like font size to Ms, then it will like cascade. So the more the nesting you do, the bigger the font will be. So this is why the Ms are really tricky to use. And there is a silver bullet for most of the situations. So those are REM, so root Ms units. So they have the same algorithm like Ms, but the big difference is that they always use the context from the root element of your page, which is HTML tag. So there is no problem with nesting for it. So if you want to use REMs, you usually start with setting the font size for HTML. So you say on the root element that my font size is 100%. Once again, this will apply the font size from the browser settings. And then this font size will become a context for all the other line height and font size computations. A few years ago, it was not so popular because it was pretty new feature in CSS, but right now 99% of devices support it. And I guess last category of relative units, those are viewport units. So basically they can add extra level of responsiveness to your CSS. So for instance, you can say font size for VW, and this translates to 4% of your viewport width. So as you can imagine, with this kind of styling, when you will resize your browser, the font size will automatically change without any media queries. So you can use viewport height, viewport width, vmin, vmax. Yeah, so like I said, so font size does this computation. So if, for instance, our device is 1600 pixels and we are using free VW, then the font size for this viewport width will be 48 pixels. If we move it, if we make it smaller, bigger, the font size will change. But as you can imagine, that can create an issue. So your font sizes can become really, really big if you have a really large monitor, or really, really small if you have a really small mobile device. But there's a solution for that as well. So to summarize, relative units provide you the benefits that changing the size of all fonts globally is easy. So basically it's enough to change the font size on the root of your page, so HTML element, and also if the user changes the font size in the browser, for instance, for accessibility reasons, the font size for your page will automatically scale. And basically that's the summary. A few words about the research. So some researchers say that the best number of characters per line is like 45 to 75 characters per line. So it's like a comfortable reading for the person. So without media queries, you may have the layout like here. So the header is really big. It breaks in the middle of the word. So pretty nasty experience. But with a really, really small amount of CSS, so with the media query maxed with 480 pixels, we can say that font size is 70%. So everything, all the font sizes on the page should be smaller by 30%. And we explicitly say that font size for the title, probably this is the title, should have explicit font size, which is specified in REMS. And as a result, you have a much better reading experience. So a sample piece of code. So how it could look like in your CSS. So you set the font size on HTML on the root of your document, and then you go with the mobile first approach. So basically you add the base styling. So this is the style that's going to be applied by default. Then if you go to the devices with bigger width, like 700 pixels, then you override it. So you say, instead of 2.25 rems, it should be 3.5 rems on the bigger device. And on even bigger device, make the header even bigger. So fluid typography. So what kind of problems the responsive typography? So problems with responsive typography, sorry. So as you may imagine, so looking at the previous slide, so when using responsive typography, you may have like dozens of this kind of media queries in your website. So that's the one problem, and so too many font size declarations to control font sizes and too many media queries. And what we would like to have is easy to maintain CSS and also a responsive typography, which is pleasant for the reader at any viewport. And basically the fluid typography can help us with that. So the idea is that the font size will change depending on the screen size. It will scale up or scale down depending on the viewport changes. And with fluid typography, we don't necessarily require media queries. So how to start with it? So first of all, when you will start working on your font sizes, there is something which is called modular scale. I think I have a screenshot on the next slide. Yeah, I do. So you will have a look, and basically in fluid typography approach, you are using the viewport width unit. So the relative unit that I mentioned, and you can also use, you have to use the calc function, CSS function, which is capable of doing mathematical operations. So in a nutshell, fluid typography is based on the calc function and the viewport width, and responsive typography is usually based on media queries. So if you go to this page, modular scale, you can play around with different parameters, and it will suggest you font sizes that you should use that are like pleasant for the eye. So you can use those numbers like 2.856 ems. It doesn't, it says ems here, but you can use rems. Basically, you can copy those values and apply them to different elements on your in your page. So basically, you don't have to think about those numbers. Those tools like modular scale will give you a hint. And then you take those values and you apply them to calc function, and you add additional one piece to the puzzle, which is viewport width. So for instance, let's say the default font size for H1 elements should be 36 pixels, which is 2.25 rems. But if the device width is larger than this value, then you say, I want my font size to be 1.3 rems plus 3.6 percentages of the current viewport width. And if the device width is really, really big, I want to prevent the font from growing too large, and I want to explicitly give it a max value. So this is the fluid thing that I was talking about. So you take the calc function, relative units, and decorate it with viewport units. So let's say let's have a look at sample implementation. So first the layout. I would like to change the layout. Yeah, there you go. So HTML. So we have H1, H2, and so on, different tags. Then we have styling. So for each font size, we have for each element we have a font size based on this modular scale. So it's decreasing for each H, and we are also applying on the body element. We are applying the calc function. So basically, we are not using media queries. We are just saying that the base font size should be 12 pixels plus the slice of the viewport width. So if we make this guy smaller, then the header font size will become smaller. This one will become really small. If we will make it larger, then the font size will get larger. So this is how it is achieved. And you can also apply a more complex formula, which is called fluid typography with locks. So basically, with this approach, you don't need to specify this minimum and maximum media query. basically using this formula, your font size will never get bigger or smaller than the border conditions. So for instance, here we say this formula, when it evaluates, it will never give you a font size which is smaller than 2.25 rems, but it will, on the other hand, will never be bigger than 4.75. The good news is that you don't have to implement those things on your own. There are ready-made libraries that handle all those too small, too big cases. CSS frameworks usually have support for this. For instance, Bootstrap has responsive font sizes, even though it's not enabled by default, but you can enable it. And in the most recent versions of CSS, there is the clamp function. So it will be a replacement for this complicated calc with locks. So basically a clamp function says that there is a mean, max value, and in the middle there is a range. So using this clamp function, you say, I don't want my font size to be bigger than 25%. I don't want it to be smaller than 100%, which is default browser size. And this is the thing which gets computed when you resize the browser. If evaluating this formula gets bigger than 25%, then the 25 pixels will be used instead of the bigger value. So it's pretty nice feature that we will be able to use in a few years. And the last category, responsive images. Okay. So for a very long time, we were using monitors that pretty much had more or less the same physical size, and using the simple image tag with the source attribute, and that had fixed width and height, worked pretty well for a very long time. But in responsive web design, we have different screen sizes, different device sizes. So we want the image to flex and change the size depending on the layout. So this one image fits all approach is not the best and not the most efficient solution right now. So we need to do something about it. So on this image, you can see that just a regular approach, no matter if we have a small mobile device or if we have large screen, we are using the same image. Basically, we don't want to do that. And this is what responsive images are solving. So the goals of responsive images is that the browser should download the image it needs and nothing more. We should provide the browser the list of available images, and the browser can choose the one that it needs. And also we want to achieve faster page loads and no data is wasted, which basically means we don't want to download too much kilobytes. So this is an example, and so for instance, if you are using the same image, then which is pretty large, so on the desktop, so it weighs 500 kilobits, then it's not a problem for the desktop. So we have pretty good CPU, we have plenty of RAM. Things get complicated when we will display this image on the tablet. We have only 2 gigabytes of RAM here, and it becomes even worse on the mobile, on our smartphones that don't have too much of the memory available. So having to keep this memory, to keep this image in the memory, will just like occupy too much of the available memory that your device has. And your smartphone can become laggy. So the solution is just to use different images for different devices. But before going into the main ways to achieve responsive images, let's talk about other like maybe not responsive techniques, but techniques that allow you to make your page look better. So if you are using backgrounds and you have a responsive page, then you can use CSS properties like background size and background repeat. And what it will do, it will basically nicely scale the background image so it looks nice on the element. So I think on one of the homeworks that you did previously, you already had like a background images. So the size of the image is not necessarily the same. The dimensions of the image is not necessarily the same as the element all on the page. But using background size contain and background repeat no repeat, you can tell the browser to do some magic with the image and just make it look nice on the element. So it, for instance, covers or contains the element. Another most basic technique is called fluid images. So by default, if you have an image tag and you provided an image with a source attribute, the dimensions of the image element will grow to the intrinsic dimensions of the image. So if the size of the image is 1000 pixels by 1000 pixels, by default it's the image tag will grow to these dimensions. You can change this behavior, but by applying simple CSS maxed with 100% and height auto. So basically it will prevent image tag from growing too much to the intrinsic dimensions of the image. And it will just use as much space as the container of the image tag provides. And you can do the same with height. So for instance, you can specify, I want my image tag to have 100 pixels in height and make the width auto. So this is like the basic technique. Those are two basic techniques for images. And also there is a third one called object fit. So if you want an image tag to feel to use a different strategies based on what the container dimension is, then you can use object fit property and just say that the image should fill the whole container. And basically there are different strategies like cover, etc. Okay, so now this is pure responsive stuff now. So since some time ago, when we started to deal with the responsive web design, a standard was extended to add a src set attribute to the image tag. So this is how it looks. The syntax is pretty simple. You have src set attribute. You provide a comma separated list of images that the server can provide. Inside src set image names, you can also add descriptors. So basically, this doesn't give the browser any information about the images. So it doesn't know that this is small, this is medium, this is large. The browser just sees that there are three different images, but it doesn't know anything else about it. So we need to give a browser a hint that about the dimension or other properties of the image. So we can say that we can tell the browser that this is the small JPEG image and its width is 400 pixels. This one is medium, it has 800 pixels, and this one is large and it has the 1200 pixels width. So this is done with the W width descriptor. And there is also a second descriptor called X, and this refers to pixel density. So what it says, it's the information for the browser. So it will say, if you are using a device with like 1x pixel density, take the small image. If you are using the device with double pixel density, take this one. I will explain what the pixel density is on a later slides. And if the pixel density is 3 times, then use the largest one. So the X descriptor is not used very often. Usually you will use it only in the situations when you have images that are displayed like a full screen mode. And you cannot mix those two, so you cannot say like 400 width and 2x. You have to specify one or another. So how it works? So if you are using the browser that doesn't support, oh, there is a typo here. If you are using a browser that doesn't support SRC set, then the SRC attribute will be used. So you will get the default medium JPEG image. If SRC set is supported, then the browser compares the current device physical width with the width of the picture, and it will pick the correct one. And the important thing to remember is that the browser is comparing those widths against device physical pixels. So, for instance, your device might have like 500 pixels for CSS, like logical pixels, but the pixel density is 2x, so it will have 1000 physical pixels. So this value 1000 will be taken for comparison. And in this particular case, so let's imagine we are using a smartphone and its width is 800 pixels, but logical pixels, but the device width is 1600 pixels. So the browser takes this value and compares it with SRC set information. It finds that there is an extra large JPEG that has exactly the same width, so I will download this guy, and others are ignored. And if, of course, if you have a different device, then this algorithm repeats and you might have a different image downloaded. But as you might imagine, this approach has one drawback. So sometimes, well, very often you don't display the images on the full width of the device. So sometimes you have a really small floating image. So this approach is good, but not perfect, and there is also a solution for that. Yeah, so like I said, so using SRC set and with descriptors, it's sometimes not enough. So there might be even cases where you need a bigger picture for a smartphone, or maybe for a tablet than for the desktop device. Okay, there is a question. It's like media screen. Just reading the question. It's like at media screen max 800 pixels. I don't exactly get your question. So this is media query that will be applied for the devices that has a width less than 800 pixels. So this media query that you wrote is for this device and this device. So I'm not exactly what's the reasoning behind the question. So if you can elaborate it, I will try to answer. Yeah, so basically there are no media queries here, at least not now. So the solution for this issue that you might have an image which is displayed only on the portion of the page is its sizes attribute. So sizes attribute a comma separated list of media conditions and widths. So basically it tells the browser what the width of the image will be in the relation to the total width of the viewport. So let's see some code. So for this particular example, if viewport width is more than 800 pixels, so we are focusing on this desktop, like big screen, then the image will take 50% of the viewport width. I think this image here doesn't take 50%, it should be like 40 here. So that's the first thing we can spot. So on the really big screens that have more than 800 pixels, then the image is taking only a slice of the size available. Otherwise, for smaller devices, we are taking the full width. So with sizes attribute, we can exactly say it with the sizes attribute. So we can say if the media query min width 800 pixels like is valid, right? So we are on this big device. Then the image will take only 40%. So basically it's a typo. So it should be 40% here. Here is already 40%. So it will take 40%. So then for a really, really big screen, the browser will compute that, like let's say it's 1000 pixels. So on 1000 pixels device, 40 VW, it's 400 pixels. So then it goes to the SRC set, it finds the image which is small JPEG, and the small JPEG will be downloaded. If this media query is not truthy, right? Then we go to this default value, which is 100 VW. And for if this value is used, then let's say we are on the device that has 800 pixels. So 100 VW is 800 pixels. So now the browser will search for the image which is best for this width, and it will find the medium JPEG. So it will download the medium JPEG. It won't get the large nor small JPEG. So to summarize, image SRC set and sizes attributes are like almost silver bullet. So they work well very often, and in most complicated situations, this is what you should use. One additional note, so basically this is one of the few exceptions in the standards where like the standards were violated. So basically, as you may know, like the visual layer shouldn't be put into the HTML, so it should be only in CSS. But this standard, like SRC set and sizes, it breaks this rule. So the guys that created the standard just decided to use this approach. So basically, you need to keep in mind that those values, if you are using similar media queries somewhere in your CSS, so basically you need to synchronize the values that you have in your HTML with the values that are in CSS. So this is like a one drawback. There is one additional extension of the image tag, so it's called picture element and source element. So when we are using image sizes and source set, we allow the browser to decide which image to use, but sometimes we as authors of the website, we want to have 100% control. And this is where we should use the picture element with source and image. So there are two use cases for using those elements. So one is progressive enhancement. So as you may know, there are different image formats. So there is JPEG, PNG, and there are also image formats that are brand new and not supported by all the browsers. For instance, web, which is like a better, smaller, better compressed version of JPEG. So it takes less kilobytes for the same image usually. So and also there are SVG images. So depending on what your browser supports, you might want to use a different image. So if your image supports SVGs, then the SVG will be downloaded. Otherwise, it will fall back to WebP. And also, if the browser doesn't know what a WebP is, then the default JPEG image will be downloaded. So that's one use case. This is not responsive, but still this is the use case for the picture. And the other one is art direction problem. So what it means, so some pictures look nice on big devices. So for instance, this guy on the water, this big picture looks really nice on the desktop or on the tablet. But imagine that we want to show the same image, of course, in the smaller size, on the smartphone. So the picture is pretty wide, so the person on the water would be really small, so you wouldn't see the details. So it would be really hard to spot what's on the picture. So art direction is just a way to say the browser if for different device widths, just download completely different image, and I want to have a control over it like 100%. So what it says. So if we are on the really small devices, so none of the media queries are truthy, then we will get a slim JPEG. So slim JPEG, that's the one. So really narrow, small image. But if browser analyzes the source attributes, for instance, this guy, so min width 800 pixels, then it will use the tall one. So that's the tall one. But if we are using the device that has at least 800 pixels, then use the square image. So here we have the square image. So that's the way of choosing the exact image that you want to download. So how it works? So yeah, already explained. So it also works in a way that if the browser doesn't support the picture tag or the source tag, it will just use the image. So if your browser doesn't support it, you will get the default behavior. And also, as with sizes, source elements must be in sync with CSS. So you have those media queries. You will have those media queries here. So usually the same breakpoints will be somewhere in CSS. So you have to keep those in sync. So now you know you need to use different images. So you need to prepare those. So when preparing the images, you need to remember about two things. So the logical width of the screen. So for instance, small smartphone might have a width like 380 pixels. The tablet might be 800 and the desktop might be 1600 pixels. But those are logical dimensions. So each device has also a pixel density. So for instance, Retina displays have 2x. So you need to multiply those values by those pixel density factors. So in the end, let's say you have like an original image, which is 3600 pixels. So you might have a different flavors. So like X large, large, medium, and small, and you may have to maintain these sizes of the images. But also remember when you will create a different images and in different sizes, just remember that sometimes you won't need those really large images because you won't be displaying them using like taking the full viewport width on the desktop devices, because for instance the image might be floating. So just keep this in mind that you don't always need it. So high definition screen, so like it's more or less already covered. So your device pixel density might vary. So from really small one, like 200 pixels to 800 pixels. And they also have like this logical width and the physical width. So, and remember that, for instance, if you have like a device which has 400 pixels in width, but the pixel density is 3 times, like 3x, then if you will download image which is 400 pixels in width, then the quality will suffer because the actual number of pixels on the device is 3 times 400, so it's 1200 pixels. So in order to pick the correct image, you can use a media query for that. So there is media feature called mean device pixel ratio. So you can replace your images in CSS using this media query. And you can use the approach already described using SRC set like 2x, 3x, 4x, etc. if you want to do it in HTML. So this is how your set of images might look like. You might have like a banner for 1x displays, for 2x displays, 3x displays, for this width, then for the bigger width, and so on and so on. And then you might need to maintain this really long list of media queries. So let's say that on the screen, which is smaller than 4 to 5 pixels, use this small image. But if the logical width is the same, but the device pixel ratio is 2, then take the same image, but with the at 2, which means like the width is doubled. Yeah, an example, the same example, but using SRC set. So 1x, 2x, 3x for different images. And probably last but not least, so SVGs. So far, I was talking about raster graphic images, so like JPEGs, WebPs, and so on. So they have a fixed width in pixels, and basically when you scale them, the quality suffers. On the other hand, we can use scalable vector graphics (SVGs), and those images scale nicely because they are defined using shapes and points, and there is a math under the hood which basically describes the image. So it's not like a fixed width image. But you cannot use SVGs in all cases, so they are not suitable for pictures like full color images, but they are perfectly fine for things like logos, illustrations, and fonts. So with SVGs, your image will scale without loss of information and quality. SVGs can even include CSS in it, so you can create an SVG which is totally responsive. So basically, it can change it how it looks. And also, they work with image and SRC attribute. So let's have a look at an example. So this is like a logo of some university. So this is SVG. So you have an image tag, you have SRC attribute that references SVG file, and yeah, basically no CSS whatsoever, basically. So it looks nice. When we try to make the device smaller, you can see that because this SVG contains CSS inside, it just decides to render itself in a different way. So pretty awesome stuff. So imagine that achieving the same result with images, it's like really painful. I would say even impossible, because the SVG is completely fluid and you don't lose the quality. So it's always sharp. And also it's really small, so the SVG needs to be downloaded only once. So once again, for things like logos, illustrations, fonts, consider using SVGs. Okay, so that's it. Thanks for attention. Any questions? Question from Jacek. Do you know something about our new task? No, not yet. So I quickly Googled. Yeah, so it's possible to forbid zooming using the meta viewport tag. So it's like an attribute. Okay, any other questions? So a question from Zana. So should we start layout from the mobile, or can we start from desktop? So the most recommended way is to start with the mobile first. So what can I say? Like that's the good practice. So often you can start with the desktop design and you may realize that the design that you came up with, it's very, very hard to implement on the smaller devices. So with mobile first approach, you just start with the most difficult way of implementing things, and then you, as your device with grows, you have bigger device, then it becomes easier. So usually that's the better approach. But on the other hand, if your main target audience are desktop users, then why not? So you can do mobile first or desktop first. You can read about those two approaches. So once again, it all boils down to your case. So if you feel that majority of the users will be coming from smartphones, from mobile devices, try to start with mobile first and add and use progressive enhancement and add features as your application as you increase the device width. Any other questions? Okay, I guess not. So thank you very much. That was my last lecture on this course. There will be, if you have any questions about responsive web design or about the homeworks, just find me on Discord. I will be very pleased to help you. So thanks a lot once again, and good luck with the rest of the course.